For our next topic, we have your naming or nomenclature of organic compounds. So under our topic here, we have your subtopics. Remember, our nomenclature is based on your IUPAC system. So that's why we also need to focus our discussion on our nomenclature systematic way of naming. Second, we will also discuss your functional groups and compound classes. So class, remember, these groupings are based on the chemical reactivity of our organic compounds. And lastly, we will also discuss polycyclic compounds because this one class is very important in the board exam. So from the previous year, they shared this is actually a pretty challenging topic. So don't worry, we will have a comprehensive discussion later on here in our video recording. So here I will give you a strategy in order to systematically name our organic compounds. Check. So in the manual, we have a detailed step-by-step process in order to name your compounds. For this discussion class, I will condense it through our strategy. First one is to define or analyze and determine the parent chain. So usually that's the longest hydrocarbon chain in your organic compound. Okay, next, after you determine what is the longest hydrocarbon chain, that will also include your priority functional group, next thing to do is to examine the substituents in order to know the prefix for substituents and suffix for your priority functional groups. Sir, do we have prioritization of functional groups? Yes. Sir, are we required to memorize it? Of course, yes na yes. Alright, so don't worry class. Here, I will emphasize our priority functional groups. Here, thirdly, after you determine your substituents present and the priority functional group with our parent chain, you can now easily assign the name. Let's see For the first two steps class, this is under our first strategy, okay? Identify the parent through the longest carbon chain and the principal functional group. Kasi usually, the highest priority functional group determines the suffix of the name, alright? Third and fourth, of course, this is under our second step. You should number the carbon chain, and then class remember, our substituents, after you identify it, its position should be in a lower numbered position, okay? So again, that's our general trend. The number of the carbon chain, of course, you need to start numbering from the end closest to the priority functional group. Next, after you determine the number of your carbon chains, again, the positioning, you now identify and name the substituents. Or remember, you need to familiarize yourselves with our IUPAC suffixes and prefixes. And fifthly, of course, the last two steps, this is under our assigning, okay? We need to assemble the name of your compound. Sir, do you have a specific examples? Yes. Let's discuss that. In order for me to discuss it slowly. First one muna, with our first step, again, the parent, alright? So we will focus first here with your parent hydrocarbon chain. Remember, it should always be the longest chain. And of course, it should also include the principal functional group. Class, when I say principal, it's just also synonymous with your priority functional group, okay? So again, remember, for instance, we have here a typical alkane. So this is just your branched hydrocarbon. I already colored in blue your longest hydrocarbon chain. Let's count again. Our parent chain contains how many carbons? So this is a line angle structural formula. So at every corner, we have carbons. So let's just first identify the parent carbon chain. All right, first 1, 2, 3, 4, 5, 6, 7, 8. Also 8 carbons. So our parent chain is, we call it your octane. Ayan. Class, again, for parent, you need to determine the longest and the principal functional group. Sir, what's the principal functional group in that example? Class, it's just a simple alkane, okay? So we will let our original parent chain as is. Okay, as is lang yung parent name natin. Next step. Again, identify the prefix and suffix by examining the substituents or side chains, and for the suffix, the parent functional group. Let's have another example. Let's see first one, identify nyo muna kung ano yung longest hydrocarbon chain natin here. Class, you can pause the video, but for now, I will discuss our parent chain for the suffix. Remember, in our prioritization, see, we have an alcohol functional group. And comparing your priority here between your alkane and alcohol, remember, you prioritize alcohol functional group. So we need to consider alcohol in our longest hydrocarbon chain. Class, for this example, we will start numbering in this direction because your alcohol should be in the lower numbered position. Starting with this carbon, 1, 2, 3, 4, 5, 6, 7, 8. Ayan. So, sir, 8 carbons in our parent? Yes. And remember, we have a hydroxyl group, so we will add a suffix all, diba? So, class, for the prefix and suffix, ayan. Check your manuals. We already summarized your prefixes and suffixes. For the prioritization, please remember, we have an increasing priority here. Let's start discussing our highly prioritized functional group with your carboxylic acid. Remember, class, our carboxylic acid, that's just simply your COOH functional group. As a suffix, it should carry with the suffix OIC or oic acid. So usually class, organic compounds, ang carboxylic acid always is a suffix because it's a highly prioritized functional group, okay? Rarely natin ginagamit yung carboxy na term as a prefix. Because for prefix, again, it is used as substituent. Going back, second priority, a derivative of carboxylic acid, we have ester. So suffix O8 and then prefix alkoxycarbonyl. Class, please read your manuals on the suffix and prefixes. Here, I will just point out our prioritization. Thirdly, we have amide, nitrile, and aldehyde. Usually class, yun lang yung important. The first 5, we have cyana. Ayan, di ba? Cyana, carboxylic acid, ester, amide, nitrile, and aldehyde. Class, I would like to point out, for amide and nitrile, usually ang suffix yan ay same lang. Amide and nitrile. For the prefix, ayan, we will replace it with amido and cyano. For aldehyde, I hope you are familiar, we use al. For instance, propanal, for your 3-carbon aldehyde, diba? Ethanal, your butanal, and so on and so forth. For prefix, we use formyl or oxo prefixes. For the next set of functional groups, we have ketone, suffix as OME, and oxo naman siya class similar with aldehyde because they are carbonyl-containing compounds. Clear? Ayan. So for our 5As, we have alcohol, amine, alkene, alkyne, alkane. Okay? So ang major confusion here, major point of confusion is the prioritization between alkene and alkyne. Usually class, napapag-switch siya ng students. They argue that alkyne is prioritized compared to alkene. Class, the prioritization here is based on the reactivity of your functional groups. Relatively, alkene is much more reactive compared to alkyne. Okay? So of course, we have an exception here because we know alkyl halide reactive yan, but due to the presence of your halogens, we have the least priority functional group here. Okay? So again, going back for alcohol, from the name itself, all as a suffix, hydroxy-OH as a prefix. For amine, alkene, alkyne, and alkane, copy lang din class yung prefixes, suffixes nila here. Okay? For prefixes, usually, ayan, similar lang with their original name. Amine, amino, alkene, alkenyl, alkyne, alkynyl, and alkane, alkyl. Alright? So, class hindi yan alkenyl ha, alkyl. For ether, we have alkoxy. So, usually hindi yan priority, backburner din yan. Okay? So, that's why wala tayong suffix for ether and alkyl halide. They are usually as a substituent or prefix. Ayan. So, class, in terms of our substituents, we also have numerous terminologies for your alkyl substituents, for our alkane counterpart substituents. Sir, important yun? Yes. Let's see. For your alkyl substituents, we have this table. This one very straightforward, class ha. Here, if we have a methane parent functional group, we will just add a YL prefix, di ba? From methane, again CH4, we will reduce it to a 3-hydrogen compound. CH3 will be named as methyl. For ethyl, of course, CH2CH3. For propyl, we have 2 isomers, si propyl, and the branching counterpart is your isopropyl. Class, you need to study this. You need to familiarize the alkyl substituents, all right? For butyl, 4 carbon compounds, see, we have how many isomers? Check the table. Again, 1 isomer is linear, the butyl functional group or butyl substituent, and the rest are all branched. Okay? So the first one, isobutyl. Second, this is your sec-butyl, meaning secondary kasi class yung substituent natin here. It is attached to 2 carbon atoms. Alright? For tert-butyl, that's just a contraction, meaning tertiary butyl. So class, quaternary carbon to. As we have seen, particularly with your neopentane. So similar siya with your tert-butyl. Okay, I'm sorry, tertiary pala. Apologies again. Tertiary rather than quaternary. As you can see, 3 carbons or 3 alkyl substituents are directly bonded to your single carbon. Alright, for your pentyl, of course, relatively class, pentyl usually hindi yan substituents. They are complex alkyl substituents. And for your phenyl, remember, this is just your benzene ring, okay? The sole benzene ring as a substituent, we have phenyl functional group or phenyl substituent. And for benzyl, we have your CH2 attached with your phenyl functional group. Again, class, that's their main difference. Si phenyl, that's just simply your benzene ring. Si benzyl, benzene ring with CH2 in its chain. Okay, don't worry, we will discuss this in our discussion on your aromatic compounds. Now we arrive with our third step. We will now assign the name. Class, remember, here is our first example. Please find some time or pause the video to guess the nomenclature or the name of your organic compound. Again, this is your octane as we have discussed in step 1. So what's next? Let's check the second step for the substituents. Again, first substituent, you should place it in a lower numbered carbon. So sir, saan tayo mag-start ng numbering? Left or right? Class, we need to put your substituents in low numbered carbon. So we need to start with your right side. Okay? So we will prioritize this substituent because it is bulky compared with your substituent here. Okay? So let's start at the left side. 1, 2, 3, 4. So C4 ang substituent natin here. And remember, this is your ethyl substituent, diba? So particularly here, we have 4-ethyl. Additionally, here class, ang position niya, what carbon? C5, and that is your methyl functional group. Check, ayan, for your methyl functional group, again, we will have your prefix 5-methyl octane. Class, in your naming, we usually position the substituents alphabetically, kahit na greater yung number ng carbon position of your highly prioritized substituent. So for here, since ethyl letter E and methyl letter M, we will firstly, ayan, name the ethyl substituent. For this specific example, we have 4-ethyl 5-methyl octane. Clear? Let's proceed with our next example. See, this is our previous example again. Octanol ang parent chain. Because of the C3 position, alcohol. Class, remember, you also need to specify the position of your priority functional group. So we only have an exception. For carboxylic acid, usually we omit the functional group or the number in the functional group because usually class nasa C1 position ang carboxylic acid. Alright? So going back here in our discussion, C3 position to since we started numbering here, di ba? From our previous slides in your step 2, C1, C2, C3, o sa C4, we have an ethyl substituent. And for C5, this one is C5. Class, remember, we have methyl substituent. So for that, we have 4-ethyl, 5-methyl. Sir, parang may kulang. Class, we need to specify the position of your priority functional group. Again, 3-octanol. So for this particular compound, we name it as 4-ethyl, 5-methyl, 3-octanol. Class, again, if you are still confused, please check your manual. You have a comprehensive guide on our organic nomenclature or naming of your organic compounds. Ayan. So remember, parent ang first step, identify the longest hydrocarbon chain with your priority functional group. Next, identify the prefix and suffixes through the analysis of your substituents. And lastly, ayan, you can assign the name already. This one, class, again, available in your manual. Your comprehensive discussion on the IUPAC system of nomenclature. Okay, so class, you can take your breaks because for now, we will jump to another topic. Medyo malapit na tayo ma-finish with our first crash course. Okay, for functional groups, remember, we divide your organic compounds based on their chemical reactivity. Class, let's proceed immediately with our discussion of your functional groups. Let's see. Ayan. As you can see here, when we say functional group, they are specific atoms or group of atoms within a molecule that determines the compound's chemical properties, particularly reactivity, polarity, and classification of organic compounds. And of course, class, these groups influence several key characteristics not only with their chemical properties, but also in their bonding mechanism, in the reactions, and the molecular geometry. Additionally, yung interaction nila with your IMFA, ayan, the induction of IMFA is also affected. And lastly, class, functional groups, they also play a very crucial role in how compounds are named and how they chemically react. First thing here, we have, ayan, your aromatic and aliphatic hydrocarbons. We have alkane, alkene, alkyne, and aromatic. Class, this one, I will just briefly introduce to you our different functional groups. So again, first group here, they are simply your hydrocarbons. So remember, they are compounds that are composed of only carbon and hydrogen. So usually they are aliphatic. So this consists of your alkane, alkene, and alkyne, or aromatic, particularly with our benzene as our main or prominent example ng aromatic hydrocarbons. Next, sir, how about that group? Anong common theme between them? Class, your alkyl halide, alcohols, ethers, and amine, they contain a class of use a C to Z, okay? Z atom wherein your Z is a relatively electronegative atom. For alkyl halide, we have your halogens. For alcohol, the hydroxyl group derived from your oxygen. For ether, OR, so again, due to your oxygen. And for amine, we have your nitrogen atom as our source of electronegative atom. So class, because your alkyl group or the carbon-containing compound is bonded directly to your electronegative atom, of course, your bonding here between your alkyl and your Z atom is polar, okay? They create polar bond, making the R group or the carbon electron deficient. So usually, they react with nucleophilic species or those compounds that are high in electrons. Energy rich, diba? So again, that's it for our second grouping of your functional groups. Third, for carbonyl-containing compounds, we mainly have your aldehyde and ketone. So again, class, they are polar due to this double-bonded oxygen to your carbon. So here, electronegative si oxygen, it will, okay? It will attract the electrons, making your carbons electron deficient. Alright? So class, as a result, aldehydes and ketones, usually they undergo addition reactions. So magdadagdag tayo ng additional functional groups in order to eliminate the double bond in their structure. Alright? Ayan. And lastly, we have carboxylic acid. So again, they contain the COOH moiety. Ayan, class. So our mother, ayan, the mother molecule here is the carboxylic acid compound. So upon reaction, you can create 4 different derivatives. See, similar lang sila class ng structure. So again, your carboxylic acid functional groups in general are polar and capable of hydrogen bonding, diba? Because of the presence of your double bonded or doubly bonded oxygen. Class, your carboxylic acid usually, among these functional groups, they have the highest boiling and melting points. Remember that again, they have the highest boiling and melting points because of the extensive hydrogen bonding in their structure. Going back, for carboxylic acid and derivatives, of course, X, this is your halogen directly attached to your carbonyl carbon. Acid anhydride. So class, this is the result when we condense to carboxylic acid, diba? Anhydride formation. For ester, this is particularly produced through esterification. And for amide, C, we have an amino group directly bonded to your carbonyl carbon. Let's discuss in particular our 4 groups here. Starting with your first functional groups, hydrocarbons. Remember, they are just composed exclusively of your carbon and hydrogen bonds. They are, please remember this, non-polar and hydrophobic. Sir, what's the reason, class? Because they are chains of C and H bonding. Recall, C and H, they are non-polar. Okay, non-polar substituent yan, class. For our 4 hydrocarbons, we have check, alkane, class, unreactive si alkane because it's just a chain of hydrocarbon. So usually kasi, for hydrocarbons, ang source ng reactivity is in your double bonds and triple bonds. So here, remember, saturated hydrocarbon yan. Of course, it will follow your octet rule. That's why, maximum of 4 single bonds. And remember, relatively unreactive ang alkanes natin. Class C, our next functional group here for hydrocarbons, we have your alkene. And remember, distinct feature of alkene, it contains at least 1 carbon-to-carbon double bond. And remember, class, this site, the double bond, is electron-rich. That's why it sites for electrophilic addition. So it will initiate an attack and it will attract electrophile. Okay? Thirdly, for alkyne, ang distinct feature, the triple bond. Remember, alkane, single bond, alkene, double, and for alkyne, triple. So as you can see here, class, linear ang molecular geometry. And comparably, in terms of reactivity, it's more reactive than alkanes, but less reactive compared to your alkene. Class, we will discuss the several reactions of your alkyne that is important for the preparation for your board exam. Alright? So lastly, we have aromatics. For aromatics, of course, ang typical structure is the conjugation of double bond. In general class, aromatic compounds follow the Hackles rule. But for now, let's just absorb o tanggapin na lang muna natin that they contain the localized pi electrons here in our conjugated double bond. So of course, due to that conjugation, your electrons can be delocalized in our ring structure. Diba? So lastly class, for aromatics, they usually undergo substitution rather than addition. Stable na kasi yung benzene ring structure natin. Alright, so that's it for our hydrocarbons. Let's proceed with our next set of functional groups for those compounds that contain a Z or an electronegative atom such as X, O, and N. So here we have alkyl halides, alcohol, ether, and amine. For alkyl halide, di ba remember, I think that's one of your hatest functional group. Ang reactive niya, it can undergo nucleophilic substitution and elimination reaction. So don't worry, we will also discuss your SN1, SN2, and your E1 versus E2 reaction. So again, that's very particular for alkyl halide. Next one, you have your alcohol. So reactive po ba si alcohol? Well, comparably, yes, it can react because it can act as weak acids or nucleophiles. And aside from that, in terms of its bonding capability, check, it has an oxygen which has a lone pair. So it is available for hydrogen bonding. Kaya pa ba class, nakaka-absorb pa? Ayan. Thirdly, ether, less reactive. Okay? So class, usually unreactive ang ether because of the bulky carbon containing substituents here. So usually, unavailable na si oxygen for reaction. Alright? So they are usually used as solvents in our organic reactions. Okay? Class, remember, These groups, majority of them, alkyl halide, alcohol ether, they increase polarity and potential for hydrogen bonding, or we also have your dipole to dipole interactions. Ayan. O last na class, si amine we have its basicity nature. Again, basic po ang amine. Highly basic, meaning it has high pH level. And aside from that, it is nucleophilic. It can initiate attack. O sir, anong reason? Class, nitrogen has an extra lone pair of electrons as an amino group. And lastly, we can classify it based on its connectivity with other carbon atoms as primary, secondary, and tertiary. Ayan, tertiary amines. Okay, so that's it for our second group of functional groups. Thirdly, we have carbonyl compounds. Remember, for carbonyl compounds, they contain the distinct carbon doubly bonded to oxygen. And because of the difference in the electronegativity of your C and O, class, remember the discussion in Gen Chem, again, there is a difference, a significant difference between the electronegativity values of your carbon and oxygen atom. That's why polar po ang carbonyl compounds natin, particularly aldehyde and ketone. You can see the main difference. For aldehyde, the carbonyl is at the terminal position. Class, in line angle structure, usually we omit this hydrogen atom. All right? For ketone, it's within the carbon chain. Ayan, it's between two alkyl substituents. Comparing their chemical reactivities, much more reactive si nucleophiles because available ang carbonyl compounds natin. For ketones, class, recall, alkyl groups, they are electron donating. So meaning the carbon, na dati or supposedly it is electron deficient, magkakaroon siya ng donor ng electrons. That's why it is chemically less reactive than aldehydes. Okay? So again, electron donating kasi yung R group or your alkyl substituents. Alright, for our last group, we have your carboxylic acid and derivatives. So here, class, again, ayan, we have four main derivatives. Our mother molecule is your functional group that contains a carboxylic acid, COOH functional group. For your derivatives, they can have hydroxyl and of course, different groups. For acid halide, you have you have halogen. Class, here in our list here, the trend is decreasing reactivity. So acid halide is the most reactive and amide is the least reactive among these four derivatives. Okay, so I discussed the specific structural feature of these four derivatives. For acid halide, usually it is used in acylation reaction because class good living group kasi yung halogen. So we will discuss this in your carboxylic acids, particularly in your oxygen-containing compounds. Again, good living group, C, halogens or halides in general. Next, acid anhydride. Of course, we have two carboxylic acids used in order to produce your anhydride molecule. Class reactive din siya, particularly with your nucleophiles. Okay, for ester, it is common as your source of fragrances, di ba? So usually fruity, okay? Fruity po ang, what do you call this, ang smell ng ester natin. Alright, sa class, again, it can undergo hydrolysis. So meaning, we will submerge it or we will expose it to water in order to revert back to your original molecule, carboxylic acid. So usually, class, using your acid or base catalyzed reactions, okay? And lastly, si amide, class, unreactive yan. This is very unreactive because of the stability of your NH2 and carbonyl group delocalization or resonance structure. So yung double bond, it can resonate in this bond or in this typical bond. O see, again, if you have a resonance structure from your Gen Chem, you are usually stable. Okay, so in biological systems, they are usually found in proteins and synthetic materials. Ayan, sa class, that's it for our functional groups. For the common names, sir, lumalabas sa boards? Yes. So here, we have the list of common names. Remember, it's also in your manual. I will just point out the very important board exam relevant topics. First one, you should be familiar with the common name acetic acid. It's just your ethanoic acid. See, ethanoic meaning, sir, meron kang two carbons in the chain. Yes. Again, we have CH3COOH, and particularly, this is a component of your vinegar, di ba? Class, next to, I would like to emphasize si acetonitrile. Di ba somehow, students are confused because they assume na IUPAC name si acetonitrile. But remember, ang IUPAC name niya is ethane nitrile. Again, ethane ang parent chain because, ang ating parent chain because of your two carbon chain. And of course, we will add a suffix nitrile because we have here your nitrile compound. Okay? So again, please remember that for our last board exam particularly important topic, ayan, we have your methyl chloride. Class, different yan with chloroform ha. Your chloroform, CHCl3. Si methyl chloride, CH3Cl. Okay? So again, common name po si methyl chloride. Ang kanyang IUPAC name is chloromethane. Ayan. So class, that's it for our common names. So again, these are the names that we use regularly or commonly. O, diba, in the lab, we usually use the common name for practicality. Okay? Ayan. O, class, to wrap up here our discussion on your functional groups and your nomenclature, let's check our sample problems here. Please pause the video and try answering our sample problems here, class. Let's check. For your first compound, easy question lang to, class, ha? Again, first strategy is to identify the parent chain. Sure, obvious, ang parent chain natin is the linear structure here. Yes, let's count. 1, 2, 3, 4, 5, 6, 7, 8. Class, again, we have here 8 carbon chain. That's your octane. Remember, for numbering ng carbons, we need to locate your substituents at the lower numbered carbon position. So class, because of that, we will start numbering at the left. Okay? So C1, C2, C3, C4. Ayan. So at C4, we have what substituent? That is your methyl substituent. Okay? So here, the IUPAC name is 4-methyl octane. Clear? Try answering the second compound here. Again, much more complex na siya because we have 3 different functional groups. We have alcohol, the halide or the halogen, and your alkane substituent, diba? Let's answer our second example. Here, we have the parent chain, again, class, our linear chain in your structure, this one. Ayan, sir, kasama po si alcohol? Yes, again, we will prioritize alcohol as our suffix in your IUPAC name. Check, alcohol is connected to your C1 carbon. So that's why our parent chain, it will carry the suffix ol. So in particular, how many carbons? 1, 2, 3, 4, 5. Class, we will start at the left because we will prioritize hydroxyl. So dapat nasa C1 carbon siya. Ayan, we have 1 pentanol. Okay, let's analyze the substituent. Step 2, your prefixes. So if this is the C1 position, at the C2 position, we have what substituent? Methyl. Okay? So again, class, remember, alphabetical po ang arrangement. So even though na lower numbered si methyl, compared to our next substituent, we will follow the alphabetical rule. So for our last substituent, we have bromine. Okay? For our prefix, we use bromo. Ayan. For C3, we have the bromo substituent. And that's it. That's your 3 bromo, 2 methyl, 1 pentanol. Okay, so class, last 2 examples before we wrap up your functional group discussion here. Okay, so here we have our first example. Again, pause the video. Let's discuss. For our priority functional group, check. What is our priority functional group? Is it alkyl halide or the aldehyde functional group? Class, remember, laging back burner or this priority C, alkyl halide. So that's why we will position our first carbon at the C1 position here in your carbonyl carbon. Sir, aldehyde pala yan? Yes, remember I emphasized that in your line angle structural formula, hydrogen in your aldehyde is usually omitted. So with that, you can see this is the C1 position, C2 and C3. So for the parent chain, our name is propanol. Okay, so remember, we need to add a suffix al for aldehyde. And for our C2 position, C, that's just your chlorine. As a prefix, we will use chloro. Ayan, so again, C2 position, 2-chloropropanol. Okay, so class, last example for our nomenclature discussion. Sir, may carboxylic acid, so automatic priority yan, no? Yes, that's correct. That's a correct assumption. So with that, we will prioritize numbering in this carbon atom. So we will proceed with numbering your first carbon, the carbonyl carbon, as your C1 carbon. See, with that, our parent chain will be this linear chain. So let's count, class. So from the right tayo mag-start. C1, C2, C3, C4, C5, C6. Sir, obviously, hexanoic acid siya. Yes. Class, again, that's your parent chain. Suffix is your oic, di ba? For your carboxylic acid. Now, from your C1, let's analyze your substituents. Starting with your C2 position, what's this? As a substituent, we name it as amino. So that's your 2-amino substituent. Again, remember, it is alphabetical, class. Last substituent we have at the C3 position, that's your hydroxy, okay? 3-hydroxy-hexanoic acid. So its IUPAC name is 2-amino 3-hydroxy-hexanoic acid. Class, absorb muna for our sample problem. I hope you got the 4 sample problems correctly. Ayan, so class, kaya pa ba? Di ba source ng stress natin or headache natin si organic chemistry? Okay, so class, that's it for our sample problems. Class, last topic for our crash course 1, we have the nomenclature of polycyclic compounds. Of course, this is a supplementary, a special topic discussion for our IUPAC naming because most of the time, PRC also, or the Board of Chemistry, also adds certain items on your polycyclic compounds. Let's see, for polycyclic compounds, we define it as molecules that contain or emphasis on 2 or more interconnected, okay? So again, they have point of connection that we call junction. So for polycyclic compounds, we have 3 main types. So the easiest one, class, is your spirocyclic compound. So formal definition of spirocyclics, it consists of 2 rings that is connected through a single atom. So we usually call that single atom as your spiroatom. So in terms of your naming, we use this general term, okay? So again, you have your spiro, so of course bracket X dot Y. And then you will add our parent chain depending on the number of carbons in your polycyclic compounds. See, for X and Y, they are C atoms in each ring, but you will exclude the spirocarbon or that single shared spiroatom. And class, take note, always for spirocyclic, X should be less than Y. So here, we will start, diba? We will start counting on the number of carbon atoms. For X, that's your, ayan, smaller ring. For Y, simply that's your larger ring. Okay? For the base name, again, class, or the parent chain, that's your total number of carbon atoms. And here, we will now include your spirocarbon. Let's check some of our examples here. Ayan, firstly, diba? Spiro-2,2-pentane. Sir, pwede pala yun? Yes. Pag equal class ang carbons in your ring, we will just include the typical X and Y number of carbons. Check natin again. Our total number of carbons for the base name, we have 1, 2, 3, 4, 5. That's why it's a pentane. Okay? Its parent chain is pentane, and we have 2 rings. For each ring, how many carbons do we have? Excluding spirocarbon, of course, 2 for this ring, and 2 carbons for this ring. I hope it's clear again, class. Let's take an example again, spiro-3,4-octane. First thing to note, your X should be the ring that is smaller, and your Y in your name should be the larger ring. Wag mako-confuse again. Let's check the smaller ring. How many carbons excluding the spiroatom? Teka lang muna, sir. Nasaan ba dyan yung spiroatom? Sa class, again, this is the junction, the point of attachment of your 2 rings. So we will exclude this in our naming system for the spiroatoms. Class, going back, for our smaller rings, how many carbons? 1, 2, 3. See, again, that corresponds to our X ring. For your Y ring, the larger ring, how many atoms? Class, please try answering this one. 1, 2, 3, 4. That's why it's named spiro-3,4. Sir, check mo nga kung 8 talaga yung total carbons. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Ayan, class, clearly, octane ang parent chain or base name natin here. Alright, for our next 2 samples, check, that's just the same, okay? So you can double check the name of this spiro polycyclic compounds. Here we have adecane because it has how many carbons? 10. And for undecane, of course, 11 na yan, class, diba? So again, later, I will flash typical sample problems for our test of knowledge for polycyclic compounds. Class, clear ba? Let's proceed with our next type of polycyclic compounds with your fused bicyclic compounds. Sir, ano pong characteristic? What is the typical characteristic or feature of your fused bicyclic compounds? Class, for bicyclics, we actually have two types. One is fused and one is bridged. Alright? So here, ang kanilang differences, for fused, our atoms, our carbon atoms are 2. The point of attachment is in your 2 adjacent carbon atoms. Let's see ha. Ayan, here, our prefix, di ba recall for spirocyclic? Spiro. For bicyclic, of course, bicyclo. And here, inside our bracket, we have x.y.0. Class, because this is a fused bicyclic, it's always 0. Okay, again, this is a constant. So the x and y are the only substituents here that will change upon the structure or upon structural analysis. And here, x and y are C atoms in each ring that will exclude the bridge heads. Okay, so class, again, this one naman, we will prioritize the larger ring first before the smaller ring. Let's see. So class, for the base name, similar lang yan with your spirocyclic. That's the total number of carbon atoms, all in all, including your bridge heads. Let's check our first sample problem. Sample polycyclic fused bicyclic compounds. Class, let's see bicyclo-110 butane. As you can see, how many carbons total, including your bridge heads? 4. 1, 2, 3, 4. That's why it's a butane, di ba? Our parent chain is butane. For the number of carbon atoms in each ring, check natin. For the first ring, this one only. For the other atom, that's 1. Another 1 carbon. Class, again, consistent. This is just a constant, always 0 because wala tayong third bridge. So mag-iiba lang yung value nito or its value will change in your bridged bicyclic compounds. Okay? Let's take your second compound here as an example. Class, again, opposite ang x and y in terms of our prioritization here ha. So spirocyclic, of course, we prioritize your small and then large rings. For our bicyclic compounds, large first before the small rings. C, for our parent chain, how many carbons for the base name? 1, 2, 3, 4, 5, 6, 7. That's why it's a heptane. For our larger ring, that corresponds to our X atoms here. Class, this one is our larger ring. How many carbons excluding the bridge heads? 1, 2, 3. And for your smaller rings, obviously we have 1, 2. I hope hindi kayo ma-confuse, class. Again, we exclude the bridge heads. Okay? For all polycyclic compounds, in terms of the naming inside the bracket, we exclude your bridge heads. Alright, last example na lang. And then for our for the fourth example, please analyze it by yourselves. Okay? Class, for our third example, please count the number of carbon atoms for our base name. 1, 2, 3, 4, 5, 6, 7, 8. Diba? It's an octane. And based on the number or the size of the rings, similar sila. So class, again, pag similar, much easier determine the number of carbon atoms for our X and Y substituents. C, for our left ring, 1, 2, 3. So that corresponds to your 3 here inside the bracket. And for our right ring, 1, 2, 3. So that's why the name of this compound is bicyclo-330 octane. Ayan. Class, I hope it's clear. Again, I will leave the last compound as an example for your own test of knowledge. Class, let's go to our last type of polycyclic. Again, this is the second type of your bicyclic compounds. If we have fused, we also have a bridged bicyclic. And this is rather confusing. Okay? Formally defined as a cyclic compound or a polycyclic compounds that share two non-adjacent, okay? Two non-adjacent carbon atoms or bridgeheads connected by one or more bridges. So class, again, pag ma-overwhelm, the structures of bridged bicyclic compounds are complex. So this is the most complex among the 3 polycyclic compounds because we have a bridge, we have a third ring, so well, relatively 3D na yung structure niya. For nomenclature, ayan, we use the same technique, but here instead of using 0 for the last substituent, we use Z. We use bicyclo, XYZ, where XY and Z, are C atoms in each bridge. And we will exclude the bridgeheads again. Or remember, for bicyclo, we prioritize for X, the largest ring, and then Y, the medium-sized ring, and Z, the smallest ring. Okay? And for the base name class, similar lang yan. You will need to incorporate or include in our naming our total number of carbons, including your bridgehead carbon atoms. Let's take our 4 compounds here as an example. So I will discuss again the first 3 examples, and then please analyze the last example. Let's check. First one, again, count the base name. For the total number of carbon atoms, we will use it for the base name. Let's see how many carbons. 1, 2, 3, 4. Sir, may isa pa above the plane of the ring. Yes, so that's why it's pentane. We have total of 5 carbon atoms. Class, again, here we have 3 ring structure na, di ba? The first one is this, the second one is this, and the third one is 3D above your plane of the ring. So that's why if we will exclude the bridgeheads, for this particular ring, we have 1, carbon here, 1, and the carbon here is 1. Sir, equal sila? Yes, much easier to deduce the XYZ atoms for your rings that are equal in terms of the number of carbon. Okay? Let's take our next compound as an example. So this is bicyclo-221 heptane. Again, determine first the total number of carbon atoms. Let's see. 1, 2, 3, 4, 5, 6. Sir, meron namang isa above the plane of the ring. This one is the 7th carbon, total of 7. That's your heptane polycyclic compound. So again, class, somehow here, meron na tayong differences sa size ng ring natin. But again, we will prioritize the rings with higher number of carbon atoms, excluding the bridgeheads. So for this part of the ring, we have 1, 2 number of carbons. So 2. For the right side, we have 1, 2. So another 2. And for our last ring, ayan class, we have 1 carbon above our ring structure. That's why it is labeled as bicyclo-221 heptane. Alright, for our last example here, class, check. Again, similar strategy, count the number of total carbon atoms. 1, 2, 3, 4, 5, 6, 7, and lastly, 8. So this is octane. For our naming, or recall, we have different sizes na ng ring structure here. So we will start with a larger ring structure. This one yan, class. See how many carbons excluding the bridgeheads do we have? 1, 2, 3. So that's why we have 3 here. For our medium-sized ring, so 1, 2, that's why we have 2. And lastly, class, ayan, finally, we have your 1 carbon atom in our smallest ring structure. That's why we label it your bicyclo-321 octane. Now, clear? All right, so class, that's it for our polycyclic compounds discussion. So at this point, let us try some sample problems here. So you can pause the video in order to try answering our sample problems. So class, please try answering for test of knowledge. Remember, important to note here that this also appears in your board exam. Let's answer our first compound here. Again, this is a, what type of polycyclic compound? This is your fused bicyclic compound. Let's answer again. First, what do you call this? So please check or analyze and determine the number of total carbons for your base name. Okay, so let's count. Starting from this junction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so sir, 11 carbons, that is your undecane, di ba? So again, undecane, and then label our nomenclature for our junctions. See, here we have your larger ring and smaller ring. Again, class, we will prioritize the larger ring first. For the larger ring, we have how many carbons? 1, 2, 3, 4, 5. And for the smaller ring, 1, 2, 3, 4. That's why our name for our first polycyclic compound, ayan, we have bicyclo 5.4.0. Sir, ba't nga 0? Because wala tayong bridge here in your fused bicyclic compound. I hope it's clear. Again, bicyclo 540 undecane. Okay, let's proceed with our next sample compound. Class, this one, I think this is challenging, di ba? So again, in our naming, we always, okay, sa positioning ng carbon, we always start with a junction if you have a substituent, all right? So again, for your typical structure ng polycyclic compound, I will reiterate, if you have a substituent, of course, you need to start numbering in your the junction of your ring. See, again, let's start with the total number of carbons. Starting with this junction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sir, decane siya. Yes. Okay, that's it. For our substituents class, we will prioritize, again, the alphabetical arrangement. Okay, and of course, based on your alphabetical and the size of your, not the size, the atomic number, okay, of your substituents, we will now position it at the lower numbered carbon. So sir, meaning we will prioritize it fluoro. Yes, because again, in terms of alphabetical arrangement, C, is prioritized compared to your fluoro F. And in terms of your prioritization based on the atomic number given by your CIP rules or familiar with your Can and Gold Prelog rules, of course, we will prioritize chlorine. That's why, ang rotation natin class, or the positioning here, we will position your chloro, ayan, at your C2 position. But before that, again, let's first discuss the junctions here and the number of your carbons per ring structure. For the left ring, how many carbons? 1, 2, 3, 4. Sir, parang same lang naman yung number of carbons. Yes, okay? For both of your ring structures, we have 4 carbons. So that's why we call this your bicyclo 440 decane. Okay, again, class, this is a fused bicyclic compound. That's why we don't need to have a value here. So always 0 lang siya. For the substituent, again, we will position here at carbon 2 because of the prioritization. And let's position your fluoro as what carbon position? So C2, C3, C4, C5, C6, 7, 8, 9, 10. That's why our name is 2-chloro. And again, si fluoro is at the C10 position. That's why it's a 10-fluoro substituent. Our final answer, 2-chloro, 10-fluoro bicyclo, 440 decane. Clear ba, class? Ayan. Class, last two problems or sample problems. This one, what type of polycyclic? This is your spirocyclic compound. Sir, how's the nomenclature will be applied here? Paano siya i-apply? Class, of course, we have a prioritization of the functional group still. So the nomenclature coming from your IUPAC will still be used here. So sir, meaning we will prioritize the hydroxyl group. Yes, okay? So again, because we have substituents, our parent chain, remember, the base name is the total number of carbons. Let's count. 1, 2, 3, 4, 5, 6. That's why this is a hexane parent chain, but again, for the suffix, we will add all because we will prioritize the alcohol functional group. Check. Ayan, hexanol. And here, class, again, is your spirocarbon. Let's first determine the small and large ring. Remember, for spirocyclic, XY, X is for the for your smaller ring, and Y is for the larger ring. First, with our smaller ring, how many carbons, excluding the spirocarbon? 1, 2. And here, we have your 2C, and for our larger ring, we have 1, 2, 3, 3 carbons. Okay, that's why we label it as spiro 2, 3. Ayan. Sir, how about the bromo? Class, we will prioritize, again, this functional group. So this will be labeled as C1. Okay, so if this is C1, we will label bromo as C1, C2, C3, C4. Okay, so its structure is at your C4 substituent ng carbon. All right, so again, that's for our spiro compound. So our answer here is, ayan, C4 again, hence 4 bromo, spiro 2, 3, hexan 1 all. Okay, so class, I hope it's clear. Again, here is our answer for our third compound. And lastly, for our bridged bicyclic compound, remember, first thing to do, or first step, is to devise or determine the total number of carbons. Class, let's count. 1, 2, 3, 4, 5, 6, 7. Class, meron tayo here, 8, 9, 10. All right, so class, again, we have a total of 10 carbons. So sir, decane siya? Yes. Okay, and then of course, for our bridgeheads, here are the bridgeheads, and then label your ring structure based on our nomenclature. Again, bicyclo XYZ, where X is the largest ring. Sir, paano pag-equal? So of course, that will correspond to your X and Y. See, for your 2 ring structure here, class, equal lang yung carbon atoms nila excluding the bridgehead. We have 3 carbons each. 1, 2, 3, and 1, 2, 3. That's why for our name, we will have 3, 3, and then for our last ring, how many carbons? 1, 2, hence 2 carbons. We will label it as bicyclo 332 decane. Clear? Sir, how about the substituents? Class, your substituents will be positioned depending or starting from the methyl junction. I'm sorry, for the junction, coming from the junction. Okay? So kahit naman saan ka mag-start here, the chloro group will be positioned at 1, 2, 3, 1, 2, 3, C3 position. Remember that ha? Always, we start with your junctions in your polycyclic compound in numbering, not in your substituents. Okay? Particularly sa bicyclic compounds class. Alright? So for your bromo, of course, here, we will prioritize your functional group. Okay? So class, that's it for our discussion ng polycyclic compounds. So I hope it's clear. Again, that's it for our polycyclic compounds, and that ends our discussion for Crash Course 1. So to wrap up our discussion, so let's proceed with our quick quest. Okay? So again, with our quick quest, we have your add one out game. I think you're already familiar with this one. So I will flash 4 different concepts and determine which is the imposter. Ayan. So again, first item, condensed formula, expanded formula, line angle formula, Bohr formula. Sir, obvious naman, Bohr formula po. Very good. Again, Bohr formula is not related. The other 3 are used for 2D representations of organic compounds. All right, next item, we have forms 4 bonds, bonds with itself, forms ionic bonds, and lastly, forms chains and rings. Sir, I think obvious din yung answer. So class, this is under our discussion of properties of carbon. And recall, your carbon, of course, it does not form ionic bonds. So form 4 bonds due to its tetravalency, multiple bonding with itself, single, double, and triple bonds, and catenation, it can form chains and rings. Okay, class, next item. We have methane, propanol, ethane, and butane. Class, which is the imposter? 3 of them are alkane and propanol is an alcohol. Okay, class, I hope you are familiar now with the functional groups ha. So don't worry, masasaturate kayo with our discussion ng reactions of your different functional groups. Okay, second to the last. With our types of bonding in your organic compounds, we have covalent bonding, ionic bonding, single bonding, and triple bonding. Sir, I guess the answer is ionic bonding. Yes. Okay. So class, that's it for our types of bonding. Remember, ionic bond, that is not a characteristic of your organic compounds. Class, lastly, with our polycyclic compounds, we have bicyclo 110 butane, bicyclo 320 heptane, bicyclo 430 nonene, and bicyclo 222 octane. Class, which is the impostor? Sure, yung bridge bicyclic po. Yes, that is your bicyclo 222 octane. Right? Class, again, our hint here is the third atom, the Z atom. Remember, for your fuse, they are always 0. For your bridged, of course, they already have a value. Okay, class, let's summarize your favorite slides, our Lars words for our discussion. Starting with our representation types. Class, first one. This shows all atoms and bonds explicitly. Sir, that's the expanded formula. Again, that's just your Lewis structure or Lewis dot structures. Next, this groups atoms together. That's the keyword. And it omits most bonds and lone pairs. Sir, is that condensed formula? Yes. Thirdly, implies carbon at line ends or corners, and it shows heteroatoms such as your O and SPX explicitly. Class, that's the last type of our 2D representation, and that is your line angle formula. For the next 3 representation types, again, they are 3D representations. Firstly, we have dash wedge. Second, we have ball and stick. And thirdly, we have space filling model. Class, again, dash wedge structure, remember, important in stereochemistry discussion. For ball and stick, aside from the bond length, it also emphasizes the angles between your bonds. So it shows atoms as balls and bonds, okay? The tiny bonds as sticks. And lastly, space filling model is the most accurate 3D representation that shows the relative atom sizes and your spatial overlap. That's why it's highly used for your steric studies, okay? Class, next summary is on our properties of carbon. Recall, first property forms 4 covalent bonds. That is your tetravalency, diba? Second, it forms single, double, or triple bonds with itself or other atoms. Sir, multiple bonding yan. Yes. Thirdly, it forms or your carbon chains can be straight, branched, or cyclic due to the strong single carbon-carbon bonding. And that is your catenation. And lastly, class, the bonding or the ability of your carbon to bond with other elements, particularly your heteroatoms to form different functional groups. That's your heteroatom compatibility. Okay, so class, that's it for our properties of carbon. Remember, in our nomenclature, we have parent, prefix, suffix, and assignment ng or assembly ng name ng organic compound. And lastly, for polycyclic, remember, we have 3 types. Spirocyclic. First one, its structural feature, it has 2 rings that share a spiroatom, or 1 common carbon atom, and IUPAC naming, here we have spiro XY alkane. Next type, 2 rings share 2 adjacent atoms and their bond. Okay, again, this is your fused bicyclic. Typical name is bicyclo XY0 alkane. And lastly, we have your bridge bicyclic feature. It has 2 rings, and the difference just a fused, it has bridges joining our 3 different structures. You have 2 rings that share non-adjacent atoms. And in terms of your IUPAC, bicyclo XYZ alkane. Class, that's it muna for our part 2 video of our crash course number 1. So for our last topic, we will start with it in our part 3 and the final video for our crash course 1. So I will see you there. Bye, class!